Hello, welcome to this lesson where we are looking at probability uh, grid. We are solving probability questions using a grid. That is what we're going to look at. This channel has all the lessons from grade 8 up to 12. For anyone who is preparing to write for exams, Examination Council of Zambia, please make sure that you watch all the presentations that have been made on this platform. You're not going to have complications with the exams. All right? Make this a class. Get yourself a book where you write everything that we present from grade 10 up to 12. This is not different from a classroom, because if anything, it's even better because you can replay the lessons. There's nothing like you missed a lesson. Lessons are there waiting for you. That is one advantage. The second advantage, you can do more than a lesson in a day. In a classroom, a teacher only comes once per day or sometimes thrice in a week. But this one you can do as many lessons as time allows you in a day. Therefore, you can finish the syllabus faster than a normal class. All right? That is another advantage. The other one is that you spend less. You spend, especially if you've got free internet, you don't pay anything. Okay? So those are some of the advantages here. So I have presented other lessons where we could solve the same questions. I think this is the fifth lesson that we are looking at under probability. So here we want to look at probability grid. How do we solve a question using a probability grid? And what is a probability grid? It is a table that shows all the possible outcomes of a trial that consists of two events. Okay? A table that shows all the possible outcomes of a trial that consists of two events. Please mark that definition. Okay? Then we have, so two coins are tossed at the same time. Two coins are tossed at the same time. Two coins are tossed at the same time. Remember, we are looking at the grid. Okay? We are looking at the grid. Two coins are tossed at the same time. Two coins are tossed at the same time. Construct a probability grid to show all the possible outcomes. A grid, like we said, it's a table. So we have, on one coin, we expect head or tail. On the other coin, we also expect head or tail. All right? So, this is how we are going to construct the grid. This is how we are going to do our grid. This is how we are going to do our grid. Okay? We may not necessarily need this box. So, what are we expecting? We can have head and head on both. Remember, we are saying two coins are tossed at the same time. So you can have head and this head. Or you can have head or tail, which is this one. Okay? Then the second one, you can have tail, which is this tail, and the head. Or you can have tail and tail. This, on the first coin, we have this. On the second one, we've got these outcomes. So when we begin to put them now in the grid, this can go with this one, this can go with this one, this can go with that. Then that is what we are expecting there. All right? That is what we're expecting. This is what we're expecting. So we have answered the first question that talks about the construction of a grid, probability grid. This is the probability grid. This is the probability grid that we have constructed, which is this part. Then we need to handle the subsequent questions using the grid that we just constructed, right? So use the grid to find the probability of getting two heads. Two heads. Where do we have head and head? Okay? Here, what do we expect? Two heads, it's talking about head and head, head. And where do we have head and head? Probability of head and head. We have, where do we have this? We have head and head, it's this one, which is just 1 over the sample space, all the possible outcomes. How many are they? We have got this, this, this. There are 4. So the probability is 1 over 4. Okay? But if we're saying the probability of obtaining head and tail, head and tail, head and tail, we have 2, so it could have been 2 over 4, then 1 over 2. That is that. This is the first one, 2 heads. The second one, at least 1 tail. At least 1 tail. At least 1 tail, it means that a tail is a must. We should have a tail. At least 1 tail. So here we have a tail, we have a tail, we have a tail here. So the probability of having at least 1 tail is equals to, we have 3 of them. 3 over the total, which is 3 over 4. Only this one does not qualify. That gives us that answers our question in full. I have shown you the grid and how you answer the questions using the grid. Okay? We go to the next one. What are we dealing with? A coin and a die. A coin and a die. So, we want to construct again a probability grid. We want to construct a probability grid. Are we together? Is it clear? Are you able to see the... Okay, yeah, I think, yeah, it's clear. So, a probability grid. Now, we have a coin. We're talking about an ordinary coin, a fair coin, an ordinary die. A coin, on a coin we have got 2 possible outcomes, which is a head and a tail. Then on a die, if an ordinary die, we're expecting 1, 2, 3, 4, 5, and 6. So this is how we construct the table or the probability grid. Okay? This is what is expected of us. Okay? So these are things that we're expecting. When you throw a coin and a die, all the possible outcomes are here. It's either you're going to have a head and a 1, a head on the tail, on the coin, and a 1 on the die or the head. Then you've got the head or the 3, head or 4, head or 5, head or 6. These are outcomes on a what? On a die. These are outcomes on a what? You know, for a coin, it only has 2 possible outcomes. Then the second one to be tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. So here we have constructed a probability grid that shows all the possible outcomes. All the possible outcomes is what I have displayed on this grid. So if the question asks you, you should know that a question sometimes can ask you to use a tree diagram or a probability grid, and this is how you construct the probability grid. Okay, so after we have done this one was a question on its own. Then we have to use it to answer the questions, and it's important that you get to know, like I talked about these numbers when we are looking at sets, even in other lessons I talked about them. These, we've got an even, numbers greater than, so those things we need to know that. So find now, using this, find the probability of getting or obtaining a tail and an even number. A tail and an even number. Okay? We want the probability of getting a tail and an even number. That is very important. A tail and an even number. A tail and an even number. A tail and an even number. Okay? A tail and an even number. Okay, so these are outcomes that we are expecting on a die here. These are outcomes that we're expecting on a die, or maybe we can write die here, then here we write what? A coin. These are coins, that's that. Then here we have now possible outcomes. These are outcomes that we expect. A head can go with any of these numbers. A tail can as well go with any of the numbers. Now we want the probability of getting a tail and an even number. What is an even number? An even number is a number that is divisible by 2. So a tail, all these are tails here, but the condition is should be tail and an even number. So it's supposed to be 5. So a tail and an even number, where do we have that? Tail and even number, this one qualifies. Tail and even number, also tail and even number. All right? How many are they? 1, 2, 3. What is the sample space? All these possible outcomes, how many are they? 1, 2, 3, 4, 5, up to 12. So the probability that we are talking about here of a tail and an even number, the probability of getting a tail and an even number, it is 3 over 12, which simplifies to 1 over 4. The first one, the probability of having a tail and an even number. If they say a tail and a 2, a tail and a 2, it is only this one here. So it will be 1 over 12. A tail and a prime number. A tail and a multiple of 5. A tail and the factor of what? A tail and... So please, we need to understand the even numbers, prime numbers, odd numbers, all those things. Then we have this one. A head and a number greater than 4. A head. The head must be there. And then the number should be what? Greater than 4. A head and a number greater than 4. A head and a number. Where do we have the heads? Here. And then the head should go with a number that is greater than 4. So 1, 2, 3, 4. All these are less than 4. This is equal to 4. But we want those that are greater. So where do we have the head and a number greater than 4? It's only these 2. So that case, it's going to be 2 over the probability where we have a head and a number greater than 4. And a number greater than 4 is equal to 2 over 12, which is 1 over 6. All right? I hope I have... So it is after you have constructed this one now, it's the question of you understanding the question. When they talk about odd number, you need to know what an odd number is. Prime number, you need to know what a prime number is, and stuff like that. I hope they are very clear. Yes. So that is what is expected of us. That is what is expected of us. So let's look at the last question. The last question involves 2 dice. 2 dice. Okay? So, you know that this is the singular, and then plural we have got what? Alright. So that is what you are supposed to note. So here we've got what? Two ordinary dice are what? Are thrown. Construct the same grid. So we have got the first we have got the first dice. We've got the first die where we are expecting 1, 2, 1, 2, 3, 4, 5, 6. Goes up to 6. Then the second one also gives us 1, 2, 3, 4, 5, 6. So this is what we are supposed to have. Okay. Then okay. Then we have this. 1, 2, 3, 4, 5, 6. Okay. This is the grid. And you know that on each die, you've got the possible outcomes. There are 6, 1 up to 6. So here we are talking about 2. So this one, these ones can represent the... So this one we can say it's the first die. Then this one can be the second die here. This one can be the second die, right? Second on top there. Now inside here we begin to put the what? All the possible outcomes. The possible outcomes. So it's a question of like we're bringing the coordinates together. So this is what? 1. Here we have 1, 2. Oh, this is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. This is 2, 1, 2, 2, and 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 4, 5, 4, 6. Okay? 5, 1, 5, 2, 5, 3, 5, 4, 5, 6. Oh, 5, 5, 5, 6, 6, 6, 6, 5, 6, 4, 6, 3, 6, 2, 6, 1. What have we done? Construct the grid to show all the possible outcomes. We have constructed the grid to show all the possible outcomes. This is the grid that they want us to do, which we have just constructed. It's very simple. This is basically, I've dealt with all the 3 that you expected. So make sure you write them down so that each time you go through, you have to write them down so that each time you remember, you need to go through this part. You don't go back to the videos. You just get your book and you go through what you wrote down. Okay? So now, we have to use this grid to answer the following questions. Find the probability of obtaining a total of 7. So we need to get the number that will give us a total of 7. When we add them, they should give us a total of 7. Those 2 numbers here, okay? Find the probability of obtaining a total of 7 from this die and the other die. Okay? So look at those numbers, like this one. Okay? Look at those numbers. Look at those numbers that give us this case. Okay? So this one gives us, when we add these 2, we get what? 7. Also, when we add these 2, when we add this one, when we add this one, when we add this one, as well as this one. Okay? I think so. Let's check. Do we have any other pair where we get a sum of 7? Let's check. Do we have do we have? So the probability of obtaining a sum of 7, a total of 7, which is a sum of 7. This total of 7 is the same as sum of 7. 1, 2, 3, 4, 5, 6. Okay? So this is going to give us the probability of getting the total of 7 is equal to, we have 6 over 36. There are 36 here. These. Please don't include the numbers. Just the possible outcomes. All the possible outcomes here. There are 36. Then you simplify this to give you 1 over 6. So that is for the first one. That is for the first one. That is for the first one. I hope I haven't left out any. Okay. It's possible you can skip one or so. So you need to pay attention. Then the same number. What is the probability of getting the same number on both die? On both dice. What is the probability? So we need, like, here we have 1 and 1. That's what we're talking about. What is the probability that you're going to obtain the same number? On this, if you've got 2 here, so here we have got the same number. Here we've got the same number. Here we've got the same number. This one gives us the same number. This one gives us the same number. This one gives us the same number. 1, 2, 3, 4, 5, 6. Okay? Again, we are going to have a probability of having the same number on both is equals to what? We have 6 over 36, which will give us again 1 over. Okay? That's that. So then the last one is the sum of the two dice. The sum of the two dice exceeds 9. Exceed 9. Exceed 9. When we add those two numbers, they should exceed 9. They should exceed 9. It appears all the answers here are giving us, all the questions here are giving us the same answer, which is unfortunate. It exceeds 9. Exceeds 9. Like it goes beyond 9. When we add this one, these two, they will give us 10. These ones will give us 11. This one, 12. Okay? Then, this one. Okay? Which other one? And this one. They exceed, they are more than 9. When you add this, the sum of two that way. So we have this case. This one. How many are they? There are 6. So it will also be 6 over 36, which will be 1 over 6. Okay, it's unfortunate that here we have all the questions are giving us the same thing, but that is not the case all the time. Okay, so you need to know, for instance, if the question was talking about square numbers, we are talking about numbers. If you have 9, 9 must go with 4. Okay, just an example. You know that these are square numbers. So we just have to know all the types of numbers. I think I have dealt with these questions, 3 of them, and this is what you expect in the exam. How do you construct the grid and how do you answer subsequent questions using the grid? And these are the questions that I thought I could present. Make sure, please, you hit that red button there, subscribe to the channel, and give us the comments on where maybe we may need to do better and stuff like that. And tell us how much you're benefiting from the lessons. Okay? So, as per our tradition, I have got the questions that I'm going to give you. An exercise. For those of you that send these questions, it's not everything that you're supposed to send. Sometimes I give you a lot. So you just do, so like here, you can do these two. This is progress, grade. No, please. This is a tree diagram. This is a tree diagram part. Not those. Ignore that part. I'm talking about this one where you need to do tree diagram we have already done. This one. Okay? These ones. So greater than 7, a square number is what I was talking about. A multiple of 4, there are numbers that 4 can go into. So there are 2 questions here. Make sure you do them. Okay? Make sure you do these 2. I can also give you something just for your practice. Where do we have that question? Where do we have that question? Oh, where do we have that question? Okay, question 18. Question 18. Question 18. Question 18 here. Thank you very much. Thank you.